Hi again. Now I'm going to talk to you about quadrants, and then that's going to build into this idea of end behavior, which is pretty simple. Now I hope you've seen this before, but if not, I've got it ready to go for you. The x and y axes can be organized into 4 quadrants, and the way they're numbered maybe doesn't quite make sense right away. There is logic behind it. It involves circles. Don't worry about it. The top right is quadrant 1, and then they progress as you go anti-clockwise around. So it goes 1, 2, 3, 4. Those are the quadrants. And they're always in Roman numerals. Again, I didn't make that up. That's just how they do it, so I'm going to do it the same way. Now, end behavior is where the graph is located on the far left. So like really far this way on the graph. I'm going to sketch one soon. It's when x is like a very high negative number. And it always starts in quadrant 2 or 3, the ones on the left. Okay, and then it progresses somewhere over here, which is 1 or 4. Okay, so I've got an example here. I want us to find the end behavior of this function, f of x equals x plus 5. All right, so I got my calculator here. I'm going to show you what window settings I use. Just this is what your calculator defaults to. So change your x min to -10, x max to 10. Same with y. And to graph something at y equals, all right, just put in x, which is this button, plus 5, and we're going to see what that graph looks like. Okay, now I'm going to sketch it on here. It doesn't need to be perfect. I'm just going to freehand it. Look something like this. Okay, for end behavior, you don't really have to do any math. It starts in quadrant 3. It ends in quadrant 1. The fact that it went through quadrant 2 absolutely does not matter. So this end behavior, all you write is 3 in Roman numerals to 1. That's what a solution looks like for end behavior. And it's pretty easy. Okay, I hope that makes sense. Next, I'm going to talk to you about x and y intercepts. Okay? X-intercepts are where a graph touches the x-axis, and this is where the function equals 0. Okay? I've sketched a cubic here, and I've highlighted where the x-intercepts are. Okay? This cubic, which is degree 3, has 3 x-intercepts, but that's not always true. A function can have anywhere from 0 to a maximum of their degree. So since this is what a cubic looks like, degree 3, there's no way it could have more than 3, but it could have 2, it could have 1, and it could have 0. Okay? This one has 3. The end behavior, just for practice, remember, our quadrants are 1, 2, 3, 4. Just like with our previous example, actually, this end behavior is going to be 3 to 1. Okay. Now I'll just talk a little bit about y-intercepts. That's where a graph touches the y-axis. That's the vertical axis. Okay. That's when x equals 0. Or when you can also say f when x equals 0 is f of 0. So that just means you place x with 0. We'll do some math with that tomorrow. That's the y-intercept. Check it out. All polynomial functions have exactly one of these. In this cubic that I just sketched, the y-intercept would be right here. Okay, where it touches the y-axis. Oops, I don't think I labeled those. There we go.